Hello, viewers. Welcome back to channel. In this section, we'll be talking about basic trigonometric equation. So this is 7.4. Now, first of all, let's discuss what's the difference between a trigonometric equation and a trigonometric identity. Now, if you look at these three examples here, this is the first one. This is sine squared theta plus cos squared theta is equals to 1. Now, this is a trigonometric identity. Now, why is it an identity? Because it is true for any value of theta. If you like, take theta to be 30, 40, for any angle theta, sine squared theta plus cos squared theta is always equals to 1. But if you look at this one, so this is an identity. But if you look at the next two, so if you look at this one you see 2 sine theta minus 1 equals to 0. This is not an identity, but it's an equation. Now, why is it an equation? Because it is only true for some values of theta, not for all values of theta. For example, now, if you take theta equals to 90, if you take theta is equals to 90, you see that this will not work because you will have sine 90 is 1. So you will have 2 times 1 minus 1, which is not equals to 0, right? But if you take theta to be 30, for example, if you take theta to be 30 here, this sine 30 is equals to what? Half. So you have half times 2, which is going to be 1 minus 1. So you see that if you substitute 30 here, it's going to solve the equation. So simply, these are just the difference between trigonometry identity and trigonometry equation. Also, this third one, it can only be true for some values of theta. All right, now how do we solve trigonometry equation? Basic one. There are some guidelines here we can use. You just try to solve for the variable. And also we need to know that we need a chart because we are looking for what? The angle in what? In standard. We're looking for our angles in what? In standard position. So that is the theta we're interested in. Now let's just take example. Let's go to the example straight. So this is 2 sine theta is equals to 1, and we want to find the value of theta. So how do we proceed? Here we can just go straight and divide both sides by 2, so that we will have that sine of theta is equals to what? 1 over 2. Now, if sine theta is equals to 1 over 2, this is possible only in 2 quadrants. Yeah. So it's either we are in the first quadrant or in the second quadrant. Now, this is what we're going to do. If we are in the first quadrant, so the first thing we do, we need to find our reference angle, which we call, I can call it theta 1. Let's call it theta 1 in this case, or theta star. So the reference angle is usually an angle in the first quadrant. Let's call it theta 1. A reference, let me write it here, very clear reference. So it should be an angle in the first quadrant whose sine theta, with the sine of that angle is what is half. And we know that this is nothing but what? But 30 degrees, right? Because sine 30 is 1. So it means that if we are in the first quadrant, so if we are in the first quadrant, right? So if we're in the first quadrant, what does that mean? It means we are like this. So this is the first quadrant. So this is our reference. Remember, our reference angle is the angle between what? The x-axis and the terminal. So this is our reference angle, theta 1, right? But now we are looking for an angle. The angle we need is the angle in standard position. So in standard position, for standard position, you need to start from where? From the positive x-axis to the terminal. So you can see in the first quadrant, our theta is the same thing as our what? as our reference angle. So this means that what? We will say that theta here is just going to be 30 degrees. Then let's go to second quadrant. If we're in the second quadrant, remember, for second quadrant, this is for quadrant 1. For second quadrant, what will happen is this. Let me just write here. It means our reference angle is this one. So what is reference angle? Reference angle is going to be the angle between the x-axis, whether negative or positive, right? Theta 1. So this is your reference. But what we are looking for is the angle in standard position, which should start from the positive x-axis up to the terminal. So this is the theta that we need. So it means, as you can see, that theta 1 plus theta is going to be what? 180. So theta, which is in standard position, is 180 minus what? Minus theta 1. So whenever you are asked to solve a trigonometric equation, the theta you are looking for is not the reference theta, it's the theta in standard position, right? So with this now, we can get, it means that if we're in quadrant 2, we can just make theta. So theta is going to be 180 minus what? Theta 1, which is the reference. So it's just going to be 180 minus what? Minus 30, and that will be 150, right? Okay, so it means we have 150 here. Okay, degree. But in general, since we can see that here, we don't have any restriction on the value of theta, so this will be our general solution. So general solution will just be that what? In the first quadrant, you can write it as theta is equals to 30 degree. You can add 2 or just 3. You can add 360, which is the same thing as 2 pi k. So you can say 2 pi, you can use k. And also in the second quadrant, you just write theta is what? 150 plus what? 360k. And here you can say that k is what? Is an integer. Now this is the solution. So why do we have the solution this way? Because we don't have a bound. There is no restriction for theta. So we write the general solution. And here, why do we add 360k? It's just what? The period, right? So you can add because of the period of sine, and sine is 2 pi. And you can put the k just to tell you about how many rotations, similar to the coterminal. Now, look at example B. Now, for example B, we just need to make some rearrangement here. With this, we can write as 3 cosine theta minus cosine theta is equals to root 2. So this will be 2 cosine theta equals to root 2. And that means that cosine theta is root 2 over 2. So this also, it means you can be in the cosine is positive, either in the first or where? Or in the fourth, right? But first of all, you find your reference, which you can call theta or theta 1, theta star. It's okay. Let's call it theta 1. So the theta 1, it's going to be 40 degree, 45, right? Because we have root 2 over 2. So it means if we are in the first quadrant, what will be our theta in standard form is going to be the same as what? Our reference, which is 45 degree. But now if we are in the fourth quadrant, what will be theta? Theta is going to be 360 minus what? theta 1. So which is 360 minus 45, which is just going to be 315 degree. Now, why is it like that? Let me explain that of the fourth quadrant. If you're in the fourth quadrant, the reference angle is going to be this one. This is going to be our theta. This is theta 1 reference. Because reference is what? Is the smallest angle between what? Your x-axis and your terminal, right? But if you want the what? The standard position, you have to go this way. So this is actually what we are interested in. So you see that theta plus theta 1 is equals to 360. And it means that theta is 360 minus what? The reference, right? So that is why we have this. Then we just add what? We just add 360K plus 360K. And here we have that K is what? Is an integer. But in this question we have, you can see we have a restriction. We want only the angles theta between 0 and what? 500. So what we can do is you can just take the values of K. You can start from K is equals to 0 because there is no any negative angles required. So if K is equals to 0, if K is equals to 0 from quadrant 1, from this first, we will have what? We will have 45 degree. And if K is equals to 0, if you plug it in here, you get 315 degree. Then we can increase our K by K is equals to 1. If K is equals to 1, I think everything will be above, right? Yes. So if K is equals to 1, you see here, you will have 45 plus 360, which will be 5 is it 505? Okay, which is already more than. Here also, if K is if K is 1, you will have around 615, I think. So in both cases, we have to reject this. So our solution is only 2 theta 45 and what's 315. All right. So this one, we have another one here. C tan squared theta, it's equals to 3, right? So for this one, what can we do? This is, we need to solve for what? We need to solve for theta also in standard position. And here, as you can see, we don't have any restriction also on what theta should be, right? So what can we do here? So let's see here. Oh, let's make a restriction here. And let's say we add just from 0 to 2 pi here. So here we can solve directly. This we just square both sides. So this means that tan theta is going to be plus minus what? Root 3. So it means we have two cases, right? We have the case when tan theta is positive root 3, right? Or tan theta is negative root of 3. So we have to consider these individual cases. So here, it means you are either in the first or you are in the third quadrant because tan is positive. So let's finish with that. And here also you can see that our reference, what is the reference? Theta 1 is going to be 1. It's going to be 60, right? So it's going to be pi over 3. Yeah. Now, it means if you are in the first quadrant, your theta is just going to be theta 1, which is pi over 3. And if you are in the third quadrant, what is third quadrant? How do you find theta in the third quadrant? The standard theta in the third quadrant, it's simply going to be, so let me do that of the third quadrant here. So in the third quadrant, it means your reference angle is this one, right? So this is theta 1. So if you want to draw the what? If you want the theta in standard notation, you will come this way. So what does that mean? That simply means that we have that theta 1 plus 180 is going to be theta, right? So simply that is what it is. All right, so it means if you want to get your theta, what do we do to get theta? Remember, we are interested in the theta in standard form. So here, actually, it's theta. The whole of theta has to be what? 180 plus theta 1. And as you can see here, that is what it's going to be. So here, it means we're going to have what? We're going to have 180 plus theta 1. As you can see, I think I have the chart here. So you see the chart. That is what happened in the third quadrant. So it means theta here is going to be pi, which is 180 plus what? Pi over 3. So we have 4 pi over 3. All right. Okay, now this is also the same. Here also we have to be in what? In the second or in the what? In the fourth quadrant. But the reference angle will remain the same. So our reference theta 1 is still what? Is still pi over 3. But if you are in the second quadrant, we know that our theta will just be what? 180 minus what? Minus pi over 3, which is going to be 2 pi over 3, right? And if you're in the fourth quadrant, our theta is just going to be 2 pi minus pi over 3. And this should give us what's 5 pi over 3. So unlike in the case where we added, you can see we added 2 pi, but the period of time is pi. So we can just add what? We can just add pi k, actually. We can just add pi k to it. So if you look at this now, you will see that pi k okay, so here said we can add what? We can just add pi k. Pi k. We can add k pi or pi k is still fine. And that is because of the what? The period of time. But if you look at these two, you can actually summarize these 4 equations. These are like 4 solutions. We can write them as 2 because we can write them as theta x equals to pi over 3 plus what? Plus k pi or pi k. And this is when k is in z. Now, why can we do this? If you look at these two, you see that the difference between them is just what? It's just pi. The difference between this and this is pi. So it means that you don't need to write them separately. You can just combine them so it will be pi over 3, which is the smallest, plus k, because now check, if k is 0, what do we get? We get pi over 3. If k is 1, you will get, add 1 here, you will get 4 pi over 3, right? Then if you consider these two, the ones coming from from quadrant 3, quadrant 4. I'm talking of these two here, this one and this one. While here, we talked about with 2, this pi over 3 and pi over 4. So these two, you can just write them as this one. Okay, k pi. But now for this two, you see also the difference is just pi. If k is 0, you get 2 pi over 3. If k is 1, if you add 1 here, 2 pi over 3 plus pi will give you 5 pi over 3. So these two also, we can combine them, and we will write 2 pi over 3 just plus what? Plus k pi. See, so this one should be the yellow one. Okay, so this is the solution for this question. Now let's go to another example. This one here. Sine theta minus cosine theta is equals to 0. And the theta now is between, I think for this one, do we have a restriction? Okay, there is no restriction here. So let's just remove this restriction. We can leave it in general. Now for D, this one has restrictions. So how can we solve this? We can write this as sine theta equals to what? Cosine theta. And then we can divide both sides by sine theta actually. Or we can divide both sides by cosine theta. But here we are assuming that cosine theta is not equals to 0. And that means that theta is not equals to pi over 2 plus n pi. So this restriction is important because if cosine theta is equals to 0, then you'll be dividing by 0, which is not possible. It does not make sense. So here, this becomes tan theta equals to 1, right? Now, this is possible in which quadrant? In the first or in the third quadrant, because the tan is what? Is positive. So if you're in the first quadrant, first of all, let's find our reference. Theta 1 is going to be pi over 4, right? So if you're in the first quadrant, your theta is still the same thing as your reference, which is pi over 4. And if you are in the third quadrant, what will be theta? Theta is just going to be pi plus what? Pi over 4, which is going to be 5 pi over 4, correct? So this has to do with what? With the reference angle. Don't forget again, let me put the chart. This is the chart here. If you're in the first quadrant, your theta is the same thing as theta 1. If you're in the second quadrant, your theta is 180 minus what? Theta 1. If you are here, theta is 180 plus theta 1. And if you're in the fourth quadrant, theta is what? Is 2 pi minus theta 1. So that is why we have pi plus pi over 4 here. Okay. Now we need to add what? We can add k pi to all the solution because we're dealing with what? We're dealing with tan. So now since we have a restriction, then we have to find which values we need, yes? So we will always start with k is equals to 0. That is because we are starting from the theta cannot be negative based on the range we have, based on the restriction we have. So if k is equals to 0, we will get pi over 4 from the first quadrant, and from the third quadrant, we will get 5 pi over 4. And if you take k to be 1, if k is 1, what do we have? We will have pi over 4 plus pi, right? Yeah, which is still going to be 5 pi over 4. So there's not much difference. Now, if k, and that is from here, but from the third quadrant, if you take k to be 1, so you'll have 5 pi over 4 plus what? Plus 4 pi over 4, which is about 9 pi over 4. And 9 pi over 4 is still less than what? It's still less than 3 pi, so it's still fine. So let's consider when k is 2. If k is 2 from the first quadrant, we will have what? We will have pi over 4 plus 2 pi, right? Yeah. But 2 pi we can write as what? We can write as 8 pi over 4. So which is still going to give us 9 pi over 4. Then if you substitute k is equals to 2 now in the third quadrant, because you have to consider all cases, we'll have 5 pi over 4 plus what's plus 8 pi over 4. And this is going to give us what? 13 pi over 4. And now I think it's enough, but you can see that we need to reject a lot of things. This definitely, we cannot pick more than 1, but this has to be rejected because 13 over 4 is bigger than what? Is bigger than 3, right? Because we need the maximum to be 3 pi. So it means that the solution is simply what's pi over 4. Yes, 5 pi over 4, but we cannot take it more than once. It's already here, right? And then we can take also 9 pi over 4 only once. And this, the solution set, is the solution set. All right, so thank you for watching. We'll continue in the next video. We'll be looking at solving trigonometric function equations by factoring.